My dear students, this particular video is going to give you for sure some 40 marks in just 10 to 15 minutes. So I would want you guys to watch this particular video till the end. In this video, Fajan's rules, spectral lines, quantum numbers, calculation of valence electrons, identification of period and group, spin magnetic moment, boiling point from Van 't Hoff vector, order of the reaction from half-life. All these short topics I shall be discussing with you in very small interval of time. So without wasting any sort of time, let's get going, let's get started. My dear students, there is a short question asked every year from your Fajan's rules. As per your Fajan's rules are concerned, covalent character that is directly proportional to polarizing power of cation, and this covalent character is also directly proportional to polarizability of anion. Polarizing power of cation depends on two factors: charge on cation, size of cation. Polarizability of anion depends on charge on anion and also is directly proportional to size of anion. These are just the factors which you need to know, and you can easily solve the questions based on Fajan's rules. Have a look exactly what I'm saying. My dear students, if you look at all these questions, over here this is Al tri positive, F negative, Al tri positive, Cl negative, Al tri positive, Br negative, Al tri positive, I negative. So cation everywhere is same. I'm not going to decide on the basis of cation. Talk in terms of anion. Charge on every anion is same, so decide on the basis of size of anion. More the size of anion, more the polarizability of anion. And more the polarizability means more the covalent character. That's it. Similarly, here you have got Li positive, Na positive, K positive, Rb positive, Cs positive. In every cation here, charge is same. So talk in terms of size. Lesser the size of cation, more the polarizing power of cation, hence more the covalent character. So this is going to be the order of your covalent character. Similarly, this is Bf negative, Cl negative, Br negative, I negative. Again, charge on every anion is same. So talk in terms of size. More the size of anion, more the polarizability, hence more the covalent character. And this particular question, right, you are going to tell me its answer in the comment section of this particular video. And over here, let me give you a hint. Over here, you get pseudo inert gas configuration, right? Based on pseudo inert gas configuration, let me know the answer of this particular question. Moving on to the concept number 2. As you all must be knowing, this is the formula to calculate total number of spectral lines when the electron makes a transition. Now, my dear students, out of the total spectral lines, how many spectral lines will fall into Lyman series? How many spectral lines will fall into Balmer series? How many spectral lines will fall into Paschen series? That's given by this particular formula, which is N2, higher energy state, minus ground state of that particular series which we are talking about. For example, what does it mean? Let's say the electron is moving from 5th shell to 1st shell. And when the electron moves from 5th to 1st, how many spectral lines in total we are going to get? We are going to get some 10 spectral lines. Out of these 10 spectral lines, how many will fall into Lyman series? It is going to be equal to, talk about the formula, N2. N2 is higher energy state minus ground state of Lyman is 1. So 5 minus 1 is 4. N2 here is 5 minus ground state of Balmer is 2. So 5 minus 2 is 3. Higher energy state N2, that's 5, minus ground state of Paschen is 3. The value comes out to be 2. Higher energy state is 5, minus ground state of bracket is your 4, that is 1. And N2 is 5, and ground state of fund series is 5, so 5 minus 5 is 0. If you take the sum of these, 4 plus 3 is 7, 7 plus 2 is 9, 9 plus 1 makes it 10. So overall 10 spectral lines are obtained, and out of these 10 spectral lines, 4 spectral lines will fall into Lyman, 3 into Balmer, 2 into Paschen, 1 into bracket, and 0 in fund. So this is how you are going to solve this sort of a short question as well. My dear students, there is one more thing, one more frequently asked question, if you all must be knowing. First of all, you must know azimuthal quantum number L. Its value is from 0 to n minus 1. Magnetic quantum number M, its value is from minus L to plus L. Spin quantum number can have two values only. One is plus 1 by 2 and another one is minus 1 by 2. Now, I have given a set of quantum numbers. You have to tell me which of the following is correct and which of the following is incorrect. My dear students, look at the first option. N values 4. L values 3. That's correct because L is from 0 to n minus 1. 0 to 4 minus 1. That means 0 to 3. Either 0 or 1 or 2 or 3. Correct. M is from minus L to plus L. So M will be from minus 3 to plus 3. Yes, minus 3 is given. And spin quantum number is plus 1 by 2. So this is the correct one. N values 4. Look at this L value here. L values 4. Can L have same value as that of N? No. L value is from 0 to n minus 1. 0 to 4 minus 1. That means 0 to 3. So 0, 1, 2, 3 are the permissible values of L over here. So this set of quantum numbers is not possible. See, N value is 4, correct. L value is 3, correct. But M is from minus L to plus L. So minus 3 to plus 3. -4 does not come into that category. So this is not the correct one. Last one, spin quantum number value is coming out to be 0, right? But we know spin always has two values only, either +1/2 or -1/2. So there is only one option that is going to be correct among all. So this is how you are going to tackle this sort of a question based on these three things, if you remember. And if you remember these three things, you're sorted over here. Now, my dear students, let's say you have got an element whose first ionization energy is 5 electron volt, second is 10, third is 20, and fourth ionization energy is 2000 electron volt. You have to tell me how many valence electrons are there in the atom. My dear students, it's pretty much simple. Let's say this is the nucleus, and for example, this is the outermost shell, right? To take the first electron out from outermost shell, to take the first electron out from the outermost shell, how much energy is required? 5 electron volts. To take the second electron out, how much energy is required? 10 electron volt. To take the third electron out, how much energy is required? 20 electron volt. To take the fourth electron out, how much energy is required? There's a huge jump from here to here. There's a huge jump from here to here. That means the fourth electron will be taken out from the inner subshell. That right? That means the fourth electron has to be taken out from the penultimate shell basically. Right? Not from the valence shell, from the penultimate shell. That's why more energy is required to take the fourth electron. So how many electrons are there in the valence shell? There are 3 electrons in the valence shell. So the element will have the 3 valence electrons. That's something which you are supposed to check. Calculate the number of valence electrons here. And the number of valence electrons here will be 3. Because the fourth electron, its ionization energy is 2000 electron volts. What does that mean? That means a lot of energy is required. So this electron won't be present in the last shell. It will be present in one shell before that. That's why more energy is required to take that fourth electron out. So only there are 3 electrons in the outermost shell, so 3 valence electrons in total. This is again a short question. Similarly, how do we calculate spin magnetic moment? My dear students, spin magnetic moment is given by the result root of n into n plus 2, where n represents number of unpaired electrons. N represents number of unpaired electrons. For example, you have got K4 FeCN6. Iron here is in dipositive state. And Fe dipositive configuration is this. You know it. Here, cyanide is the strong field ligand. If cyanide is a strong field ligand, it is going to cause the pairing of electrons. And when it causes the pairing of electrons, there won't be any unpaired electron. That means n value is 0. If n value is 0, my dear students, spin magnetic moment here is going to be 0. If n was 1, if there was one unpaired electron, then put the value of n as 1 here. If there were 2 unpaired electrons, put the value of n as 2 here. So this is your homework question. Do let me know its spin magnetic moment in the comment section of this particular video. Moving on, my dear students, to one more thing. Remember, when the solute undergoes dissociation, boiling point at that time is directly proportional to Van 't Hoff factor, and Van 't Hoff factor is directly proportional to the number of ions produced by the solute. For example, you have got NaCl, BaCl2, AlCl3, Na3PO4. So when NaCl goes into the solution, how many ions it's going to give? 2 ions, Na positive and Cl negative. BaCl2 will give 1 Ba dye positive and 2 Cl negatives. So in total 3 ions. This will give 3 Cl negatives, 1 Al tri positive, 4 ions. And this will give how many exactly? This will give how many? Let me just erase this option. Let me keep only 3 options over here so that it'll be easier for you. So basically this is giving 2 ions, this is giving 3 ions, this is giving 4 ions. More the ions produced, more is going to be the Van 't Hoff factor, more is going to be the boiling point. So boiling point of the third one is going to be maximum, followed by second one, followed by first one, right? If this was first, if this was second, if this was third, I would say third one will have maximum boiling point, followed by your second one, followed by your first one. Your freezing point of the solution, that's inversely proportional to Van 't Hoff factor. So my dear students, if I ask you what would be the freezing point order, freezing point order is going to be reverse of it. Freezing point order is going to be reverse of it. So more the ions produced, lesser is going to be the freezing point. So remember this particular question as well. Similarly, my dear students, there is one more frequently asked question. That is calculation of order from half-life. Calculation of order from half-life. I want you guys to remember this particular result. Okay. Half-life 1 divided by half-life 2 is equal to initial concentration 1, initial concentration 2, whole raised power 1 minus n. What does it mean exactly? For example, you have got a question here. You have got the reaction A gives B. When the initial concentration of reactant was kept as 50 molar, at that time half-life of the reaction was 4 seconds. When the initial concentration is 100 molar, half-life is 2 seconds. When the initial concentration is 200 molar, half-life is 1 second. So we have to check basically what is going to be the order of the reaction. My dear students, let me just do one thing. Let me call this as A1. So this will be T half 1. Let me call this as A2. This will be T half 2. So what I'll be doing exactly, I'll be putting these values into this expression. So T half 1 is 4, T half 2 is 2, is equal to A1 by A2. A1 is 50, A2 is 100, whole raised power what? 1 minus n, where n represents order. So this value comes out to be 2. This value comes out to be 1 by 2 raised power 1 minus n. So I would say 2 is equal. 2 is equal. Take the reciprocal. It becomes 2 raised power n minus 1. So my dear students, from here you can say n minus 1 value is equal to 1. So n value comes out to be 2. So I would say order of the reaction whose data is given to me, that is 2. So remember this particular result. This is a very important question, my dear students, which is frequently asked nowadays. Now, in order to calculate the period number, how do you calculate period number of the element? Highest value of principal quantum number, that gives me the period number of an element. Let's say you've got an element whose configuration is given to me, right? So what is the highest value of quantum number here? Highest value of principal quantum number is 3. So period number of this element is 3. Highest value of principal quantum number is 4. So period number of this element is 4, right? Similarly, how do we check the group number for S block elements? For S block elements, group number is number of electrons in NS shell. Let's say this is the electronic configuration of some element, right? And the element belongs to S block. Perfect. So how many electrons are there in the last S? Only 1 electron. So the element belongs to group number 1. How many electrons are there in NS? 1 electron. So this element belongs to group number 1. Perfect for S block. For P block, it's going to be 10 plus sum of NS and NP electrons. So NS is equal to 2 electrons, NP is equal to 6. So 6 plus 2 makes it 8. So its group number is going to be 10 plus 8, that makes it 18. Similarly, it's going to be 10 plus 7, that makes it 17. So these are the group numbers of the respective elements whose configurations are given to us. When it comes to D block elements, it's going to be simply sum of n minus 1d and ns electrons. So this is your n minus 1d and this is ns. N minus 1d carries 6 electrons, ns carries 2 electrons, so 6 plus 2 makes it 8. So the element belongs to group number 8. Similarly, all your F block elements, my dear students, they belong to the third group. All your F block elements, they belong to the third group. So this was a short session, my dear students. So please do watch this session. On priority, make its notes. I'll be providing the session PDF of this particular session on my Telegram channel, which is Wassim Bhat Chemistry Official. WASSIM BHAT Chemistry Official is the Telegram channel name, wherein I keep on sharing all the session PDFs of these sessions in that particular Telegram group. So do join that Telegram group and I'll keep on coming with these sort of sessions.